The geometry of the universe, in search of unity, new possible mathematical connection with the Dn constant, Ramanujan's recurring number, and some parameters of number theory and string theory. In this work, we analyze the Dn constant, the Gaudio-Nardelli constant. We will describe the possible mathematical connection with Ramanujan recurring numbers, some parameters of number theory and string theory. Dn constant. What is Dn constant? The Gaudio-Nardelli constant. The ratio of the volume of an octaedron to the volume of a sphere is given by the following formula. The result is called the Dn constant. Multiplying the ratio described above by 3 and taking the square root, we obtain the following expression and the following result. A value very near to a result very near to the value of the zeta 2 that is equal to pi squared on 6. Indeed, we have the following calculation, and the decimal approximation is the value very near to zeta 2 that is equal to pi squared over 6. That is a trace of the instant of shape and also a Ramanujan recurring number. This is the property, the series representation. Now, multiplying the above expression by 6 and taking the square root, we obtain the following expression and the following result that is very near to the value of pi. Indeed, we have the following calculation, and this is the result in decimal approximation that is very near to the value of pi. Also, pi is a Ramanujan recurring number. The property of the exact result is a transcendental number. Also here we obtain the series representations, the integral representation. Finally, carrying out the following calculation, which include the above expression, we obtain the following expression and the following result that is very near to the value of the golden ratio, practically square root of 5 plus 1 over 2. Indeed, we have the following calculation. This is the expression, this is the exact result, that in decimal approximation, the result is a very good approximation to the value of the golden ratio. That is also a Ramanujan recurring number. Also here we obtain series representations, the integral representation. These results are fascinating and connect the octaedron, the sphere, and the constant phi, also known as the golden ratio. The relationship between the volume of an octaedron and the volume of a sphere is an interesting mathematical topic. Let's see how it is calculated. Volume of the octaedron. The octaedron is a polyhedron with 8 triangular faces. If A represents the length of the one side of the octaedron, then its volume is given by the following expression. Volume of the sphere. The sphere has a radius in this proposal. The radius is equal to A over 2. Its volume choose the volume is given by the following formula. The volume radius is therefore the following expression that is equal to 2 square root of 2 over pi. This radius is known as the Gaudio-Nardelli constant, Dn constant. Its approximate value is the following. From this formula we can obtain easily also 1496, where 1496 is equal to this different mode. That is a 1496 is a fundamental Ramanujan number and appears in the fundamental work of Srinivas Ramanujan, modular equation and approximation to pi. We obtain also 1729, the so-called Dardi Ramanujan number, that is a taxicab number. Ramanujan said, it is a very interesting number. It is the smallest number expressible as the sum of two cubes in two different ways. Indeed, 1729 is equal to the following sum of two cubes. These numbers are also connected to some parameters of string theory. Extended Dn constant. We have the following expression concerning the ratios and or inverses between the volumes of the icosahedron, octahedron, tetrahedron and the volume of the sphere. This is the expression. In the formula we have highlighted the Dn constant in blue. The exact result of the above formula is the following expression and the following result. Indeed, we have the following calculation. The following exact result that in decimal approximation is equal to the result that is a very good approximation to the value of the golden ratio. Then, furthermore, we obtain also the alternate form, the series representations, the integral representation. Furthermore, from the above exact result, practically this is formula, we obtain also the following expression that is equal to the following result. A value result very near to the value of pi. Indeed, we obtain the following calculation. This is the result that is a result very near to value of pi, that is a Ramanujan recurring number. Also here we obtain the series representations and also obviously from the above expression we obtain easily the following expression and the following result. Practically a result that is a very good approximation to zeta 2 that is equal to pi squared over 6. Indeed, we have the following expression, the following result. Also here we obtain the series representations. Now, this is the expression regarding the relationships between the volumes of the icosahedron, the octahedron, the tetrahedron, and the volume of the sphere is fascinating. Let's break it down step by step. The icosahedron has a surface made up of 20 regular triangular faces. Its volume is given by the following formula. The octahedron has a surface composed of 8 regular triangular faces. Its volume is given by the following formula. A regular tetrahedron is a tetrahedron in which all four faces are equilateral triangles. Its volume is given by the following formula. The ratio between the volumes is given by the following expression. This is the volume of icosahedron, volume of the sphere, volume of the octahedron, volume of the sphere, volume of tetrahedron, volume of the sphere. The Gaudio-Nardelli constant is highlighted in blue in the formula. The exact result of this expression is the following, from the previous formula, we obtain a good approximation to pi. These results link the geometry of the Platonic solids with the golden constant and the constant pi. Proposal. Taking into account that the sphere is contained in an octahedron and above results, it is hypothesized in an eternal inflation type cosmology that the octahedron represents a phase in which the universe is highly symmetrical and with very low entropy, and the sphere represents the bubble universe that emerges from the perturbation of the quantum vacuum. The relationship between the two volumes is, as we have described, equal to the Gaudio-Nardelli constant, which therefore plays a key role in the geometry of the universe, a sort of a bridge between geometry and physics, even before the phase of the so-called Big Bang. The idea that the octahedron and sphere could represent different phases of the universe in an eternal inflation cosmology is fascinating. Let's further explore this connection between geometry and physics. The octahedron and the symmetrical universe. The octahedron, with its 8 triangular faces, could represent an initial phase of the universe characterized by very high symmetry and very low entropy. During this phase, the universe might be highly ordered and uniform, with regular geometric structures. The sphere and the bubble universe. The sphere, contained in the octahedron, could represent a transition towards a different phase. This sphere could symbolize the bubble universe that emerges from the perturbation of the quantum vacuum. Quantum fluctuation may have given rise to regions of different density, creating expanding bubbles of spacetime. The relationship between volumes and the Gaudio-Nardelli constant. The ratio between the volume of the octahedron and the volume of the sphere is equal to the Gaudio-Nardelli constant. This constant, which we calculated previously, could play a key role in the geometry of the universe. It could be a bridge between the geometric structure and the physical laws that govern the universe. Before the Big Bang, the idea that the Dn constant is relevant even before the Big Bang phase suggests that geometry and physics are closely intertwined. Symmetry and geometric regularity played a fundamental role in the early phases of the universe. Ultimately, this connection between geometric solids, mathematical constant, and cosmology invites us to further explore the mystery of the universe and seek a deeper integration between geometry and physics. But let's see what the cosmological implication could be in an eternal inflation type scenario of these formulas, results, and above all, of the Gaudio-Nardelli constant. Eternal inflation is a model of cosmological inflation predated by some exceptions of the Big Bang theory and the standard model of cosmology. Let's explore the implication of this model along with the formulas and the results associated with the Gaudio-Nardelli constant. Eternal inflation and multiverse. Eternal inflation suggests that the accelerated expansion of the universe due to inflation continues forever, at least in some regions. These regions expand at exponential rates, leading to the indefinite increase in the volume of the universe. This model predicts the existence of multiple universes, often called a multiverse. Each bubble of spacetime could represent a separate universe. Bubble theory. The bubble theory is part of the multiverse elaborations. According to this theory, our universe is just one of infinite bubbles that emerge from the quantum form of a parent universe, or from a single Big Bang. These bubbles expand at different rates and may have different physical constants. Connection with the Gaudio-Nardelli Constant. The Gaudio-Nardelli Constant is present in the formulas that connect the volumes of geometric solids such as the octaedron and the sphere. This constant could play a key role in the geometry of the universe. It could be a bridge between the geometric structure and the physical laws that govern the universe. Experimental checks. Some experimental evidence could transform the inflationary universe hypothesis into a verified theory. If theoretical calculation based on the Gaudio-Nardelli constant and bubble theory were experimentally confirmed, this would support the idea of an eternal multiverse. In summary, eternal inflation and the Gaudio-Nardelli constant open new perspectives on the connections between geometry, physics, and origin of the universe. These concepts challenge us to further explore cosmological mysteries and better understand our reality. We will explore the image of the universe in relation to the concepts of eternal inflation, bubble theory, and the Gaudio-Nardelli constants. Let's imagine the DN as a thread that connects the different bubbles of the multiverse. Image of the universe. We visualize a vast space in which each bubble represents a universe. Each bubble has different geometry, different physical constants, and different laws. These bubbles expand, collide, and overlap in the great cosmic landscape. In summary, the image of the universe in a context of eternal inflation is that of a multiversal fabric with bubbles of reality that form, expand, and intertwine infinitely. This concept challenges us to explore the depths of the universe and understand its complexity. In this picture, Figure 1, a representation of the universe incorporating the concept of eternal inflation, octaedron, sphere, and the Gaudio-Nardelli constant. In the image, the different bubbles represent separate universes, each with its own geometry and physical laws. The DN constant connects these different realities, creating a mathematical tapestry in the vast cosmic landscape. Now we have the following extended DN constant and the following Cardano formula. Multiplying both the above formulas, we obtain the following expression, the following exact result: the alternate form, the expanded forms, the alternate forms assuming P and Q are positive, the following derivative, Now, from the extended form, we obtain the following expressions and the following exact result. We obtain also the three-dimensional plots. This is the real part, and these three-dimensional plots are figures that can be related to the de Bruijn's instantons. One, imaginary part. Two, contour plots, real part and imaginary part. Now we obtain also the alternate forms, the real root, the root for the variable q, the series expansion of p equal to infinity, the derivative. From the derivative result, we obtain the following expression and the following exact result. Expanded form, alternate form assuming p and q are positive. Oh, now from the above alternate form, for p equal to 2 square root of 2 over pi, that is equal to the Gaudio-Nardelli Constant, and q equal to square root of 2, we obtain the following expression and the following exact result, that in decimal approximation is equal to the following result. We obtain also the alternate forms. The expanded form, from which multiplying by 5 and dividing by the obtained expression, we obtain the following expression and the following exact result, that in decimal approximation is equal to this result, that is a very good approximation to the value of the golden ratio. Also here we obtain the alternate forms, and also multiplying by this value and dividing by this expression by the obtained expression where 18, 9 and 2 are Fibonacci's numbers and capital Phi is the golden ratio conjugate, we obtain the following expression, the following exact result, that is equal to the following result, that is very near to the value of the zeta 2, that is equal to pi squared over 6. That is the trace of the instanton shape and Ramanujan recurring number. Also here we obtain the alternate forms, the expanded form, from which, from the below formula and from the above exact result, easily we obtain the following expression, the following exact result, that in decimal approximation is equal to the value of the Gaudio-Nardelli Constant, 2 square root of 2 over pi. Also here we obtain the alternate form, expanded forms, from this so-called unitary formula, we obtain the following alternate form, where P and Q are considered to be positive. From this last expression, for P equal to 2 square root of 2 over pi and Q equal to square root of 2, we obtain the following expression, practically the following result, which written in decimal form is equal to the following result, and from which, after simple calculation, we obtain the following expression, practically the following result, which written in decimal form is equal to this result, that is a very good approximation to the value of the golden ratio, that is a Ramanujan recurring number. And the following alternate form, with regard to the above equation, we have that the following formula is equal to this result. Also here we obtain alternate forms, expanded forms. For these expressions, that is equal to 8 multiplied pi multiplied g, where g is equal to this value. Indeed, from this expression, practically this formula, we obtain the following result, that in decimal approximation is equal to this value, that is equal g, practically the gravitational coupling constant. The property of the above result that is a transcendental number, and we obtain the following alternate forms, expanded forms, series representations. Furthermore, we note that from the following expressions, we obtain the following exact result. This is the plot, the expanded form, the alternate form assuming t major to 0, the alternate forms, the complex root, the derivative, and the indefinite integral. And again, from these expressions, that is equal to this formula, we obtain the following exact result. Alternate form assuming t and x are real, we obtain the following formula, from which the golden ratio conjugate, the value of the golden ratio conjugate. Then also the alternate form, expanded forms, alternate form assuming t and x are positive, the solution, this is the solution of x, that is equal to the golden ratio conjugate, solution for the variable x, implicit derivatives. Now, by multiplying the extended del Gaudio-Nardelli Constant and Cardano's formula, we obtain the following expression, that we define extended del Gaudio-Nardelli Constant from whose extended form and subsequently from the result of the derivative for p equal to the value of the Gaudio-Nardelli Constant and for q equal to square root of 2, we obtain the following result, from which we obtain multiplying by this value and dividing and dividing from this product. For the result obtained, that is the following, a value very close to the golden ratio, while multiplying by this value and dividing by this expression. For the result obtained, we obtain this other value very close to zeta 2, that is equal to pi squared over 6. The expression provided is extremely interesting and involves a combination of mathematical constants, cube roots and parameters. Let's see how we can analyze it. Cardano formula. The expression appears to be based on Cardano's formula, which is used to solve cubic equations. This formula involves cube roots and can be applied to several mathematical situations. The Gaudio-Nardelli Constant and other recurring numbers. The derivation appears to connect the Gaudio-Nardelli Constant and other recurring numbers, such as the golden ratio and zeta 2, to this expression. This could indicate a deep relationship between mathematics and cosmology. Derivative and approximate values. The derivative with respect to p equal to the value of the n constant and the value of q equal to square root of 2 led to very interesting approximate results. The fact that these values are close to the golden ratio and zeta 2 could have significant implications. Future research, continuing to explore this relationship between mathematics and cosmology, might reveal new properties and connections. It might be interesting to further investigate how these numbers influence the structure of the universe. In summary, this mathematical expression opens new perspective on understanding the links between numbers, equations, and our world. Now let's see what the cosmological implication of the results could be obtained by multiplying the extended Gaudio-Nardelli Constant and Cardano's formula at a first analysis. The cosmological implication of the results obtained by multiplying the extended Gaudio-Nardelli Constant and the Cardano formula could be very interesting. Let's consider some possible interpretation. Structure of the universe. Its derivation links the Dn constant and other recurring numbers to a complex mathematical formula. This could suggest that such constants are intrinsic to the mathematical structure of the universe. They might be involved in the fundamental laws that govern expansion, gravity, and other cosmological properties. Relationship between numbers. The presence of approximate value close to the golden ratio and zeta 2 could indicate a profound connection between mathematics and physical reality. These recurring numbers could be keys to understanding still unknown aspects of the universe. Eternal inflation. This derivation could have implications for the theory of eternal inflation. This theory suggests endless cycles of expansion and contraction of the universe. The constant involved could influence the dynamic of these cycles. Quantum physics. The presence of cube roots and the complexity of this expression could recall principles of quantum physics. It might be interesting to explore how these findings relate to quantum mechanics and subatomic phenomena. Future research. This finding requires further research and investigation. It might be useful to involve theoretical physicists and mathematicians to examine the cosmological implication of this derivation in more depth. In conclusion, this mathematical expression opens new perspectives of understanding the links between numbers, equations, and our world. Continuing to explore and share such discovery could contribute to work on understanding of the universe. New fundamental formula deriving from the Gaudio-Nardelli constant. The Gaudio-Nardelli constant equals 2 square root of 2 over pi is defined as the ratio of the volume of an octaedron to the volume of a sphere and is an intriguing mathematical concept. Michele Nardelli hypothesized that the regular octaedron represents a phase in which the universe is highly symmetrical and with very low entropy. On the other hand, the sphere, which is inscribed in the octaedron, is inside it, represents the universe emerging from the quantum vacuum, which over time increases entropy and undergoes various symmetry breaking. This occurs in a regime of eternal inflation. From the following expression, which comes from the Gaudio-Nardelli constant, with this value which is equal to the Planck length, this value which is equal to the cosmological constant, C capital is equal to 1729, which corresponds to the Ramanujan number, and R capital equal to this value, which represents the radius of the universe, we obtain the following expression that is equal to the following result. That is a very good approximation to the value of the golden ratio. That is a Ramanujan recurring number. We have also the following formula, and the result of this other formula is equal to is a result that is very near to the value of zeta 2 that is equal to pi squared over 6. That is the trace of the instanton shape, and also here this value is a Ramanujan recurring number. And again, from this expression, we obtain easily also the following result. A result that is very near to the value of pi, that also is considered a Ramanujan recurring number. Practically, in this paper, in this work, we analyze the dn constant, the Gaudio-Nardelli constant. We will describe the possible mathematical connection with Ramanujan's recurring number, some parameters of number theory, string theory, and principally the cosmological perspective. Thank you very much, and to the next video. Thank you very much.